Hello everyone, welcome to our demo video about using Cumulocity IoT in a thin edge. My name is Murat Bayram and together with my colleague Yvonne we are going to show you a thin edge example we realized based on several real-world use case scenarios. With Cumulocity IoT we come across with many use cases in the industry, whether it's condition monitoring, alerting or the detection of anomalies. All of them can easily be realized with the Cumulocity. Some special type of use cases we see quite often is a real-time quality decision inside a production. Examples for that, for example, the parts creation on CNC production centers from DMG Mori, where the whole process can take less than 300 milliseconds. Another example is Dürr, where the painting process is supervised on a millisecond range in order to tag car parts that were not painted good enough. Or as a last use case together with SMC, where the covering status of bottles in the food industry is monitored for every single bottle. Many of those production processes are high-speed related, and thus an edge architecture is the architecture of choice due to latency and bandwidth difficulties. Since the Cumulocity also runs natively on edge, a very common architecture is to deploy the full platform on edge and connect all machines directly. Raw data analysis and aggregations are thus done on server side. However, this scales inefficient with increasing number of machines, especially if many processes should be supervised in terms of quality decision based on high-speed data. And since many machines are equipped with hardware that could be basically do the pre-aggregation and decision, the question that arises is, why not use the compute power on machine side to pre-analyze? And that's the whole idea of what we call the thin edge. Ewan will tell you more about it.
Okay, so with the question asked by Murat before, we need some piece of software, and let us call it thin edge, that is located right next to the machine, which does some magic and sends the output to the Cumulocity platform. Let us have a look at how to fill this magic with content and specific functionalities. The overall idea of a shop floor architecture based on a thin edge, which has a conglomerate of different components orchestrated by the unit with a Docker-based solution. This includes analytics services like streaming analytics to do calculations in real time and to do kind of scorings using machine learning models with our predictive analytics service. The communication between thin edge and machine based on MQTT, because this is the common industry standard protocol. To communicate with the platform, you can either use MQTT or HTTP REST. This logic is also containerized as a service that we are calling agent. We have one agent that is doing the device registration to the platform and another agent that is doing the analytics model administration. Now we are starting with the question, who are the personas who will work with such a solution and what are their benefits? To sum it up, we have defined 4 personas. One is the technician who is responsible for the device connectivity and who must install the thin edge software next to the machine side. So he is the only one who works directly with the thin edge. All the other personas will work on the platform side and they benefit from the direct connection of the machine to the platform. Like for example the process engineer, who wants to monitor his machine and who wants to define rules when the machine produces crap. To do that, he used the well-known Cumulocity IoT analytics builder to define analytics models and unroll them to the specific machine. The data scientist benefits from the Cumulocity Data Hub to get access to all relevant data through a single interface, but he is not restricted by using various analytics tools like Python, R, Power BI, or Tableau. It doesn't matter. Also, to roll out machine learning models are quite easy using the Cumulocity machine learning app by using the machine learning industry standard protocol, which is called PMML, or using Onyx. And finally, the manager will also benefit from the increase of machine data when he's using the Cumulocity cockpit, and he easily can create his own OEE dashboard. Finally, we are finished with the introduction and technical deep dive. Now we will jump to our live demonstration and advise you how to set up the open source ThinEdge and install it on your Raspberry device. So please, Murad, go ahead.
There are basically two steps for the demonstration you have to do in advance. So the first one is that you need the ThinEdge web application, so something that is based on the device management of the Cumulocity, slightly tweaked, that needs to be uploaded in your tenant. So if you go on GitHub, and you can see that we used the repo here on GitHub, you will see a release and also some demonstration and documentation how to install that. Just guide you through the very basic steps here. So there are releases in here. So when you click on that, you have the availability here of the already finished application, which is called C8Y ThinEdge app. You can just download this and then go into your tenant. So this is a demonstration tenant of mine. You will go into applications, and there in the tab of own applications, you can just, by clicking add application, you can upload the microservice in here you just recently downloaded. And what you will see then here in the application switcher is something we, for demonstration purposes, called ThinEdge management in here. So when you click on that, because I already uploaded this application in my tenant, then you will see something that looks actually very familiar to the standard device management with some tweaks we will go into in a minute. What we also have is another repo in here, also on GitHub, which is the actual ThinEdge based image, so to say, based on Dogger. So meaning, and there's also some README files and a documentation on how to install that, also how the different containers talk to each other. So basically, this is where you start from the edge device. I have a Raspberry Pi here running in my network, so it's a Raspberry Pi version 3 I'm using here. So the first thing you have to do is actually you have to git clone the repository. So it's downloading the repository now, and if you check on that inside the directory, there are many components that are required for this demonstration or for this ThinEdge client. So there's the agent that does the connectivity to the platform and handles the operations. There's also a Parma standalone running here on the Raspberry Pi later on. There's the Docker Compose file that actually orchestrates the different containers. We have a Mosquito, so an MQTT broker in here, but also a simulator that is generating high-frequency simulation data. And we do have a start bash script that we are using to run the whole demonstration. One thing you might adapt is the identifier that the agent is using in order to register on the platform. You will find that in the directory of agents, then in config, in the config.ini file. And there you see a section that is called device, and the identifier here I'm using for the demonstration is demo 0815, so make sure you change that and use another one. So the first thing we are doing on the Raspberry Pi now is actually just starting the start bash script. And what it's doing in the backend is it's downloading all the containers and images that are required, and you see it starts here in a Parma standalone. and Mosquito MQTT broker, but also the simulator. And in this demonstration here, this was rather fast because I was already running this on this Raspberry Pi. So when you do this the very first time on your Raspberry Pi, this might take a while because you're downloading a lot of images. So the next thing is I will go to my tenant. Within this tenant, I already went to the ThinEdge management application. As I already said, this is very similar to the standard device management. And within devices, we will now do the device registration. So when I register device, and I mean the process itself is well documented on our webpage, what you can do in here is the general device registration against the device ID, which you remember is as I put in here. So when I send that, then the platform itself awaits that this device registers or tries to register on the platform, and you see I can now click remove or accept, and when I do so, when I click on accept, the Raspberry Pi will itself receive its own credentials and can then communicate with the platform. If I go now to all the devices, so my device list, I see that the device in here, so the gateway demo 0815, is now a device within our device management with all the tabs in here that are supported by the agent that is running on the ThinEdge. So that's the info that just shows the standard device data. Also, I can put in a required interval in here. The next one is the type of measurements. So I do have the possibility in here to check what is the CPU load on the Raspberry Pi currently, what's about the disk, what's about the virtual memory, so I can take a sneak peek into what's happening on the device itself. We also, and this is nothing special related to ThinEdge, but to the device management itself, is also the functionalities of configurations. So what I can do in here is I can change configuration in a binary way, meaning I can, for example, change the debug level. I could also change how often the information from the device itself, so meaning CPU, virtual memory, etc. is sent. And if I click on save, then this operation will be sent to the device agent, and the ThinEdge, and this is what I can check on control, will then afterwards change the frequency it sends data to the platform. What is also included in this demonstration is everything around the remote access. So the agent can be used to jump from that point to any particular endpoint. Is it VNC or SSH? So this can be used for remote access from the platform side. So what I can do here is I can add an endpoint. And what you see here is there are several protocols, so meaning VNC or SSH, but also Telnet, which we definitely not recommend. So from a device-centric point of view, I enter the IP address I want to jump to. In terms of VNC, this is not user-related, but I just need a password. So when I save that and I click on connect, then the operation will be created by the platform, and the agent itself sees this operation and then will basically open via WebSocket connection that I can look here on the Raspberry Pi and now have a visual interface to interact with the Raspberry Pi in here through the platform. Those are basic functionalities of the device management of the Cumulocity. What you see in here are those two tabs. One is called Analytics, which will be shown in a minute by Yvonne, but the other one is a Docker tab, which will give you the ability to see all the containers that are running on the Raspberry Pi, and even allow it to orchestrate, modify it, and create new ones. What we see here is that there's a container running that is called Simulator. We will see that in a second, that this one generates raw data in a high frequency on the MQTT broker, Mosquito, you see here as a container as well. We also have a Parma standalone in here, meaning that we can use streaming analytics on the Raspberry Pi for pre-aggregation purposes before sending the data to the platform. We see the CPU load in here, we see the RAM and also the container ID. And from in here, I have the possibility to stop the container, restart it, or even configure and remove it. So giving in here the possibility with the powerful functionalities of operations to allow the Raspberry Pi creating new containers and monitoring it from the platform side. What I could also do is I can create new containers. So meaning if I need something, a new container, for example, in Node-RED, I can just give it a name. I can use the image I want to use for that. And I also put in the port mapping that is required so that I can access it. And if I save this, then there will be an operation created that the Raspberry Pi in this case should use this image with that name and that ports in order to ramp that up. And what you see already, and this is pretty fast, so because Node-RED was already running on this Raspberry Pi, is that it got the operation, it updated it to executing, and it also updated it that it did this successfully. So what I can do now is I can use the host of the Raspberry Pi, since I'm in the same network, and check and see that Node-RED is as an instance here running on the Raspberry Pi. So I could use it now in order to generate some flows and some logic, but I could also check here in Dogger and see that Node-RED is running here since 41 seconds with the container ID and make it manageable in here. As I already said, we have a simulator up and running, and since Yvonne will use this for high frequent data, I will just show what the simulator is doing. So I'm basically connecting to the MQTT broker that is running on the Raspberry Pi. And if I subscribe, you will see that in a high frequency, we are just randomly simulating distance positions here on raw position 1 distance, which will in a second then be used by Yvonne.
After the technician has registered his device to the platform, for me as a process engineer, I can finally start with creating new analytics models to monitor my machine and to get notified if something goes wrong. To do so, I have two options. One is using the Apama APL app. This solution is used by people who are feeling very comfortable with programming and coding. If this is not the case, then there's also a second option, how to do streaming analytics on my machine. The second one is the Analytics Builder, which is a fully UI-driven application for modeling new analytics models. Together we will now create a new model. Now we are seeing the model editor. On the left-hand side, there's a list of different kinds of analytics blocks, where we can easily build our streaming analytics workflow via drag and drop. To do analytics on our ThinEdge, we select our pre-registered device, drop it to the workflow, and then select what kind of raw input values we want to further analyze. Now we have a lot of different options how our workflow should look like. Do we want to calculate an average or standard deviation? Or do we want to link the input with other sources? Or maybe we want to run machine learning models right on our ThinEdge. All this is possible without any coding efforts. Let's do a small example. with an average calculation. Just link those two sources together, defining the window duration time when the calculation should be done, and finally define the output where the result should be published. After defining your workflow, just save it, go back to your overview, and because we don't want to run this model on the platform side, but on the ThinEdge side, we now have to go to our ThinEdge gateway application to upload this model right on the device side. Going back to our ThinEdge device, now we'll have a look on the Analytics tab. Here we see an overview of all kind of analytics models, starting with the EPL models till predictive analytics models. In this view, we can see what kind of models are already running on the device and which are not. Let's have a look how an analytics model's activation flow looks like. Just by shifting the slide, I have triggered an operation to 1. Upload the model to the device, and 2. To execute it. To see if the operation was successfully, I can switch to the Control tab and see how the status of the uploading process is. If the operation was successful, now I can see that in the Measurement tab, the aggregated measurements receive the platform, and even my new analytics will be calculated. If you want to start with our ThinEdge solution by yourself, please feel free to download our project from Git and start with the Cumulocity free trial tenant to connect your Raspberry ThinEdge very fast and easily. Have fun!